Greetings, and welcome back to my series called The Dead Sea Chronicles, in which we're looking at the geological origins of the Dead Sea. As we've explored in previous installments, the Dead Sea is a remarkable archive of Earth's history. But beyond recording climate changes and lake level fluctuations, this unique body of water also holds within its sediments a detailed record of seismic activity in the region. This seismic history not only provides us with crucial information for understanding the area's geological past, but also intersects with human history and even biblical narratives. In this part of the series, which we're calling Sodom, Gomorrah, and the seismic history of the Dead Sea, we'll explore how geologists decipher this record, what it tells us about the region's tectonic activity, and how it might relate to historical events, including the destruction of Sodom and Gomorrah, described in the book of Genesis, and a number of other earthquakes recorded in the Old and New Testaments. But before we dive into that specific seismic history of the Dead Sea, it's really crucial that we understand how earthquakes leave their mark in sedimentary records. You might be wondering, how do we know that earthquakes have had the past by just looking at sediments? Well, the key lies in a structure known as a seismite. And that serves as we're going to think of as little geological time capsules that preserve evidence of ancient earthquakes. You're looking at one right here. This is a seismite from the Dead Sea sediments. And so what you have here is you have nice horizontal layers, right? This have been sediments that have falling material collecting at the bottom of the Dead Sea. And those sediments are then building up, and the differences in colors, right, might represent grain size and chemical composition as the climate changes, or as there's annual cycles, as there's different seasons represented there. And then you have this funny little convoluted area here where it looks like there were layers of sediment here, but the layers got all sort of jumbled up. They got contorted right here. And then immediately above this section, we have additional horizontal layers that are undisturbed. That's kind of a strange sedimentary feature. What could account for this mixing of the material? Well, as you already know by now, this is thought to be an earthquake. An earthquake caused this. So what are seismites? Well, seismites are sedimentary features formed by earthquake-induced deformation of soft, water-saturated sediments. Wow, that's quite a sentence. All right. Earthquake-induced deformation. Again, you're looking at a layer right here which is deformed. You would expect even horizontal layers at the bottom of the Dead Sea for reasons that I'm going to show you in a few minutes. But you would expect those to continue to pile up at the bottom of a lake. And yet there's this deformed layer. This would have been the surface of the lake floor, right? And so that would be recent sediments that had fallen. They would have been very water saturated. They hadn't been desaturated. You might find out how they get desaturated. Well, as you have sediments compact, all right, you eventually have them become dewatered, meaning the water comes out from the pore space and then you can get compressed. You can compress the layers, right? As they become compressed, right, they become more firm. Eventually, they're going to lithify and turn into rock, right, much farther below. But on the very bottom of the lake, right, the surface of the bottom of the lake, that's going to be very soft there, right? And these layers get contorted. So then what happens is they end up getting sandwiched between uncontorted layers. Because after all, after the earthquake happens and things settle down, right, more sediments get deposited on top of them, and they're horizontally layered out and they're undisturbed. And so you get these little bands in the sediment profile of these disturbed areas, and we can interpret those as seismites, as earthquake related. So before we talk just a little bit more about exactly what's happening there, just let me show you a couple more pictures so you can have those in your mind when we go over the description. So here's a paper, The Significance of Giant Seismites in the Pleistocene Baza Paleo Lake. All right, so in southern Spain, there's a paleo lake. That means an ancient lake in which we just have the preserved lake sediments for us. And in those lake sediments, there are seismites. And so just looking at panels B, C, and E over here from a figure from that paper, there's a space where there's a cut through these lake sediments, and we have lots of horizontal band sediments. They're not very clear here. And then there's this really wild mixing or bending of these layers, forming these unique structures. And then immediately on top of those, we go right back to thin horizontal laminations, right? Probably representing couplets of annual rings, basically, that you can count up. And so you have layers below, seismite, layers above again. So what exactly is going on with seismite formation? Well, when earthquake strikes, right, sends seismic waves through the earth. In water-saturated sediments, the waves can cause a phenomena called temporary liquefaction. Right? And then because those sediments are losing their strength, right, they begin to act more like a fluid. I mean, you know what happens to the lake water above, right? If the ground moves over a foot very, very rapidly, well, the lake water doesn't move right with it, right? It kind of falls behind, and then it's going to start to slosh as it tries to catch up. Think of the same thing as happening with those sediments, right? The sediments are in the very, very top layers at the bottom of that lake because they're water saturated and become liquefied, right? As the land moves underneath, the layers below move to the side, they don't move as quickly and they can sort of swirl, they can like contort, little pieces can get broken off from below and get shattered and then get carried up into the liquefied parts, right? A number of different things can happen, which I'm not going to read the descriptions of all these, but you get deformation structures, you get mixed layers, brecciated layers, you get injection structures, material from below, from maybe cracks or, move up into it, right? A bunch of stuff is happening, right, during an earthquake, which can create these disturbed layers. Right? And what does it take? What does it take to create a disturbed layer that we could see years later looking at the sedimentary record? Well, it's thought that it takes about a magnitude 6.5 earthquake to create and produce a seismite. Under some conditions, the thought that like maybe as low as like a 4.5 magnitude earthquake could disturb enough that we might be able to detect it. But most of the seismites I'm going to show you are thought to be all from large earthquakes. Now, here's where it all becomes relevant to the Dead Sea. We've looked at some deep sediment cores in the previous episode. 450 meter or 1,475 foot core that's been cored down through the center of the bottom of the Dead Sea. And in that, counting through the layers of sediment that are seen, there's more than 400 large earthquakes that are recorded. In other words, there are 400 discernible seismites in that 450 meters, which we would say would be the result of 400 separate 6.5 magnitude earthquakes spanning 220,000 years. That's their estimate for how much time is represented by that 450 meter sediment extracted below the Dead Sea. Now, in the Dead Sea, one of the most common types of seismites are these mixed layers, where distinct annual laminations, those would be your little thin layers that we're talking are usually couplets, which represent a single year of sedimentation. Those laminations get disrupted and they get homogenized or twisted and turned. Now, these mixed layers are particularly valuable to paleoseismologists, just a fancy term for scientists who study earthquakes from the past. Because they're easily identified, as I've shown you here already, and they can be dated, and we'll talk about the dating methods for them. Now, I do think it's really important to point out that not all disturbed layers are seismites. Not everything that looks like pictures I've just shown you are caused by past earthquakes. Similar structures can be caused by other processes, such as underwater landslides. You can have rapid changes in sedimentation, bioturbation. You might have organisms that are walking around on the bottom of that lake. And they're rooting through the bottom soil, right? Like filter feeding through that sand. And as a result, of course, they're going to mix up the layers that had been laid down. That's bioturbation. Very, very common way to this is where a geologist who has a lot of experience with a lot of different situations is able to discern between what's a seismite and what might be one of these other features. So some of those criteria might include the lateral extent of the deformed layer. Is this just a little deformation in one little spot, or can you trace the deformation across many, like hundreds of feet, right, of sediment? Across different locations that might be, miles away? Do you see the same deformation at the same position in a core of sediments? And it turns out the Dead Sea is particularly well suited for preserving seismites due to a number of factors. Now, first of all, it's a hypersaline lake. If you haven't figured that out by now, well, you apparently haven't watched the previous episodes of the series, right? The Dead Sea is called the Dead Sea because it's extremely salt, high salinity levels. And that extreme salinity of the Dead Sea prevents most life forms from surviving. And since you're not going to have large multicellular organisms walking around disturbing the bottom sediments of the lake, well, that is one of the primary ways you could obscure or create what might look like false seismite structures. So we don't think that that is a contributing factor. But let's combine it with three other reasons. So there's rapid sedimentation. Dead Sea Basin experiences relatively high rates of sediment accumulation. You might be thinking, boy, a couple millimeters doesn't seem like very rapid, but that's actually quite a bit for large lakes like the Dead Sea. So even if there's a centimeter or a couple millimeters per year of sediment that's laid down, that's going to be plenty to bury and preserve seismites. And then there's the tectonic setting. After all, I mean, in order to have seismites, you have to have earthquakes. And if you have to have earthquakes that size, you got to be pretty close to a fault. And by this point, you know the Dead Sea Basin is on an active Dead Sea transform fault. So that ensures there's going to be a supply of seismic events over time. And one of the things we want to know is like, how frequent are those events? That's something we can learn. That's why paleoseismologists do what they do, right? They want to understand past earthquakes. And what they're really interested in is the past frequency of earthquakes and how large those earthquakes are. And by looking at seismites, they can do some calculations and make some then future projections about when you might expect the next earthquake to occur. And then lastly, there are varve sediments in the Dead Sea, right? We've talked about these annual couplets in which you can count up the years. And because of that, you then have a really high resolution chronological framework for dating the seismites, right? If you can count from one seismite to the next, the number of annual rings, right? The varves between the two, you could say like, if I knew when this particular earthquake occurred, like I had a historical record of some huge earthquake in the area, and I can relate it to a particular seismite, and then I count up the rings to the next seismite, then I know that there is another earthquake that many years away. So we'll look at some of that as well. You put these four observations together and you realize that the disturbed layers in the Dead Sea sediments are most likely seismites. They fit all the criteria. And as a result, we have a detailed and continuous record of seismic activity stretching back tens of thousands of years in this area. The record not only provides insights into the frequency and the magnitude of past earthquakes, but also helps scientists assess what I just said, the seismic hazards that are there today and there potentially in the future as well. So with all the new techniques for drilling, bringing up cores, scanning those cores with various different technologies, imaging abilities, to be able to have even finer scale resolution for these seismites, right? We've been able to increase a very detailed picture of the Dead Sea's seismic history. And that detailed record isn't just over the last few thousand years, but it actually extends back tens and even hundreds of thousands of years. So let's take a quick look at a couple papers that examine some of the earthquake record in the Dead Sea Basin. So here we have from Quaternary Research in the year 2000, Holocene earthquakes inferred from a fan delta sequence in the Dead Sea Graben. And I showed you this image earlier. This comes from this particular paper in which they're showing, again, the horizontally undisturbed layers of sediments. And then suddenly there's this disturbance. And so that, again, tells us that at that point when that particular layer was disturbed, it must have been at the surface, all right, or at the bottom of the lake, the surface layers of the bottom of the lake. And then you have horizontally layered sediments above them, and they just continue on again. Here's an article from Earth and Planetary Science Letters from 2004, Recurrence Pattern of Holocene Earthquakes. Recurrence pattern would be like, how often do earthquakes happen during the last 10,000 years? Along the Dead Sea transform, revealed by varve counting and radiocarbon dating of lacustrine sediments. Lacustrine just means lake sediments. So now we've got three things in here. We've got seismites. We're going to have varve counting. In order to assess how often earthquakes happen, you have to count the number of years or have some way of knowing how many years it is between each one of these particular seismites. And then radiocarbon dating, which is another form of dating of these. And so this is the most important figure from that particular paper. All right, so I want to show you that what we're looking at are sediments from a core from En-Gedi, which is a location right along the shoreline, the current shoreline of the Dead Sea. And so a core has been taken there, and it's about, like 20 meters in depth. And over those 20 meters, we're really just looking here in this particular figure at the top 3 meters, so a little over 9 feet of sediment. And what's notable is the top 9 feet of that sediment covers a little over the last 2,000 years. And so they've done very detailed, fine-scale examination of this sediment profile. And what you're seeing here is today, right? That's the surface, the current surface of the lake. Remember, the lake used to be a little bit higher. It's been drying down. And so right there, there's no longer any new sediments being laid down in that particular spot. Not long ago, it was below the surface of the Dead Sea, and therefore sediments were accumulating. And they have been for thousands of years. And so what you're seeing here on this line right here, that's the most important thing to see in this figure, is this particular line represents the varve count, right? So you're taking the actual couplets that you see there, and you're just doing, year 1, year 2, year 3, year 4, moving backwards in time. And it's a nice even slope, right, over the 3 meters. So you're working your way down the core. And as you do so, you're basically adding the varves up. And although some of the varves can be a little thinner, a little bit thicker, right? Because each year is a little bit different in terms of, how much sediment got brought in. But overall, it's a pretty consistent rate of sediment deposition in the Dead Sea for the last 2,000 years. And then what you have at the bottom here, which you probably can't read these individual dates, but these are all different dates, AD 1927 and so forth. And some of these, and these represent dates from different points on the varve count. And some of these represent earthquake. So 31 BC is one we're going to talk about a lot in just a few minutes. 31 BC is famous for a very large earthquake that occurred in the Dead Sea region. And if you take that, these gray bars here represent disturbed sediments. Right? So there's disturbances there. And the disturbances is actually a little hard to count the varves because sometimes the varves get mixed up, right? They get messed up in there. But nonetheless, you have these gray bars, and the thickness of the gray bar represents something about like the size of the amount of material that got deformed there. The more deformation, probably the larger the earthquake at that particular location. And so when you put this all together, see, like if you count up the varves and you count the number of years between the earthquakes, and then you have known reference points, so like 31 BC, and there's several other large earthquakes that are known from historical records, and you can figure out like where those are in the sediment column, then you can use those in order to identify the dates of other earthquakes that maybe you don't have historical records for. But message here is that the lake has been accumulating sediments relatively even pace for 2,000 years. Earthquakes have been happening for 2,000 years. And the varve count adds up quite nicely in terms of the number of years from 2,000 years ago to present, but also from one earthquake, known earthquake, to another earthquake. The number of varves, or the number of annual rings between the two, matches those dates, all right? Within, 1 or 2 years. There's going to be miscounts in the varves. Remember, we're looking at millimeters sometimes, of width of varves. And there is the possibility that there could be like a double couplet in 1 year if there's some unusual climatic event. But nonetheless, the fact that you can count 2,000 varves, it covers about 2,000 years, tells you that typically the annual couplets, the annual laminations that you're seeing truly are annual. They represent years. Let's give you a little better idea of what you're looking at here. I have these great set of images from Dr. Mark Wilson. And this is one of my favorites. I haven't shown it yet, I don't believe, in this series. This is a recently eroded channel from basically flash floods into the Dead Sea sediments. So where this man is standing is on what used to be the bottom of the Dead Sea. Right? Remember, the Dead Sea has been falling precipitously over the last 40 years. And so if you went back 50 years, you'd be standing in the Dead Sea at this particular location. And so all the sediments you're seeing here in this little canyon that has formed, right, are those layers of sediments that have been laid down while this was a lake. And they're still soft, right, because it hasn't been that long. And so it hasn't it's consolidated enough that it's not like mud anymore, but it hasn't lithified to the point where this is rock yet. Right. And so as a result, because the lake has gone down and now it's farther away, and we have all this exposed surface, which was the lake bottom before, now the streams have to go farther out to get to and dump their load into the actual Dead Sea. And so as they do that, of course, they're just eroding down into the material here as they go. So this is another picture from one of these eroded gullies. You're looking at about maybe 20 feet deep here, maybe a little bit more. You do see a whole bunch of rocks here at the bottom. You're like, well, where do the rocks come from? I mean, this was the bottom of the Dead Sea, and so you have fine sediments falling out. How do you get these large rocks? These rocks would be more like, these are cobbles that are brought down from the mountains, all right, around, because you're going to have flash floods, rapid water coming down the sides of the mountains, and then it's coming down and spreading out across what used to be the bottom of the Dead Sea. They wouldn't have gotten this far in the past because they would have dumped into the edge of the Dead Sea before, and immediately the rocks would have fallen out, and only the fine sediments would have gotten out more toward the middle of the Dead Sea. But now that you have the Dead Sea retreating, well, these rocks are being brought farther down and covering this area. By the way, remember we talked about how low the Dead Sea could go? And we mentioned that 235 meters below this point, if you were to, drill down here, there is a layer of pebbles, all right, a layer of larger rocks that's way out toward the middle of the Dead Sea. And so that suggests that that's what happened, that this whole area was dried up, and therefore the streams brought these rocks much farther out toward the center of the Dead Sea and laid them down in a layer at that point. And then when the Dead Sea rose up again, right, and the lake levels increased, then those pebbles no longer could make it to the center of the lake, and that's why you just have fine sediments for tens of thousands, if not hundreds of thousands of years. And so that's a nice illustration here of all these rocks being brought from the nearby mountains. Here's a nice illustration of just the amount of sediment you're looking at. Now you might be wondering, like, okay, so what does that sediment represent? Is that, how long does it take to have that much sediment laid down at the bottom of the Dead Sea? What you're looking at is this is about 20 feet here. Depending where this is and how close it is to the edge of the Dead Sea, this could be something like 4,000 to 8,000 years of sediment. 4,000 to 8,000 years in order to pile up this much sediment. Remember, I just showed you that core from Engedi, and they were looking at 3 meters, so 9 feet, representing just 2,000 years. You're adding up 2,000 couplets. The carbon-14 dating also suggests it's 2,000 years. And as the whole point of this particular episode is that we know about a particular earthquake at 31 BC. And because we know exactly where that is in this profile, all right, based on the varve count, based on the carbon-14 dating, and the size of that particular seismite, we're pretty sure that we know how long it's taken for these sediments to be laid down. Now, this is a little thicker section right here. So here we're looking at, that's why I'm saying, and since this is a little thicker section, that's why I'm saying 4,000 to 8,000 years of sediment deposition. And so now back to one of those images from before. This is actually on the side of one of those canyons. So this is recently eroded material, allowing us basically just look up at the side of the canyon and say, like, oh, I can read down the history, right, of these layers. And I see 2 significant seismites in those particular layers. I really like this particular image. I think it's easy to visualize what happened here. You have all these beautiful horizontal laminations. They've been there for a while because this represents, 40 or 50 years. They've been dewatered, and so now they are fairly firm. So then these, 10 or 15 years of sediment deposition that were at, near the the bottom of the lake at that time, right? They're softer, they have more water in them. And so as soon as the land begins to move, one direction or the other quite rapidly, these layers all move right along with the land below it, because it's connected to the sediments below it, connected to the segments below it, connected to the segments below it, and so forth. So this whole region just moves suddenly. This stuff just isn't connected in the same way, right? It's not firm enough to hold on. And so as it moves to the side, all of a sudden it just it just starts to twist around. So what's not as clear from this picture is that above this, there's a bunch of horizontal laminations once again. Now we're finally at the point where we can start connecting seismites in the Dead Sea sediments with actual historical observed events, especially ones that are recorded for us in Scripture. But in this case, historian Josephus provides us with one of the best records of a particular major earthquake in 31 BCE. And that's the one that we want to focus on for a few minutes. So let's focus on that particular time period. Here's an article from International Geology Review, an early first century earthquake in the Dead Sea. So from 2011. This article examines a report in the 27th chapter of the Gospel of Matthew in the New Testament that an earthquake was felt in Jerusalem on the day of the crucifixion of Jesus of Nazareth. We have tabulated a varve chronology from a core from En-Gedi. I showed you where that was earlier. On the western shore of the Dead Sea between deformed sediments due to a widespread earthquake in 31 BC and deformed sediments due in the early first century earthquake. The early first century seismic event has been tentatively dated to AD 31. The varve count is not perfect because there are slight disturbances, potentially by even other very smaller earthquakes, that make it difficult to have a completely accurate count. So what we have here is we're going to have this 31 BCE earthquake is very well known, well documented due to its enormous destruction that it caused, and easily identifiable in the Dead Sea sediments. I don't really know anyone that disputes the 31 BCE seismite, right? That this big earthquake caused this disturbance in the sediments at this particular place. So now you have this 31 BCE one, and they're saying, well, we counted up the varves above it, right? The layers that were laid down after that particular earthquake when that particular location was below sea level. And we've counted up a certain number of varves, and we get to a 31 AD count, plus or minus 5 years. But anyway, that 31 AD count is sort of in that range of hey, that's about the time of the crucifixion of Christ. And there's a record in scriptures of an earthquake at that particular time. So that particular seismite might represent the one that's mentioned in the Bible. So what's that 31 BCE seismite look like? Here we have it right here. This area right here is all completely mangled, right? This picture is not clear at all. I couldn't find a better image of this particular location, but it's a fairly thick section that has been jumbled up. And then we have a bunch of annual laminations. Again, they're not terribly clear. You have to look at these through spectrophotometry and other things to see this better than with the unaided eye. And then you have this layer up here, which is another event, another seismite, which is about 60 years later. So that's the two things here. I just pulled a piece of a very large figure from this paper out, so you could see what they're doing here. We have this yellow stuff are clastics. Clastics are detrital layers. And then you have this bluish layer with the white spots. That's evaporites. All right, so salts and other things. And then the pink layer is mixed sediments, of which you don't see any in this particular portion that I've pulled out here. But what they're showing here is that here's 4 BC, 5 BC, 6 BC, 7 BC, 8 BC, right? 10 BC, 11 BC. Now down here, you see 12 right here, very, very thin. 13, much, much thicker. 14, thin. 15, even thinner. So the annual couplets are different widths. because presumably, right, if you had a lot more rain or a very large rain event that brought a lot of sediment into the Dead Sea that particular year, you would get a thicker layer. And then another year, it's not rainy at all. Or maybe it's much, much hotter. You get more evaporation, you get more evaporites. So you can see some of these have thick evaporite layers. Well, how thick? I do want to show you that. Right over here, we've got depth. We're at 2,775 millimeters. So that is 2.7 meters. And then this is 2,775, and this is 2,780. So this is 5 millimeters. That's half a centimeter. This is half a centimeter. So this segment right here is 1 centimeter. So within 1 centimeter, we have, multiple years of couplets there. So these are very thin layers. So they are very difficult to count. And when you get a thin layer like this down here with year 12, right, you have to see the fact that there is an evaporite layer there. If you miss that, you might be tempted to go and just say, like, this is 1 year and this is another year, 11, 12, and skip that one. So that's why the plus or minus 5, right? And how confident are they in the varve counts? One of the ways they test these things is they take a core and then they do the high resolution photography and stuff like that. And they'll give it to different people and have them do varve counts, like different varve experts. And they'll decide, this is how many varves I count. Somebody else counts a different, does another count. Somebody else does another count. Maybe they take a different core because they've done multiple cores in some of these spots. And somebody else might get a little bit different core varve count. And in that other core, maybe they get a slightly different varve count. You take that all together and say, I saw 60 varves, plus or minus 5. So your error rate is fairly high, over that particular segment of the core. Point is that the 31 BCE seismite is very clear in this core. And then there's another disturbance higher up, and there's around 60 rings between the two. But all of what I've done so far is a build up to talk about one particular paper, which is going to involve our primary theme in this series, which is trying to understand the evidence for an ancient Earth and how this is such a challenge to those who don't believe that the world is very old and believe it's very young, only several thousand years old. This really is one of my favorite pieces of evidence. And we're going to use a young Earth creationist to illustrate how old the Earth is. We're going to do so by looking at Steve Austin's work on biblical earthquakes. So here's an article from the Institute for Creation Research from 2010 by Steve Austin, who's a PhD geologist. He's talking about the greatest earthquakes of the Bible. So he thinks about what he lists actually 17 earthquakes that are recorded in scriptures. So what Steve Austin is doing is he has published multiple articles, not just this one, but this is the most important one. He's published several articles arguing that the Dead Sea Seismites can be correlated with specific biblical events, including the destruction of Sodom and Gomorrah. That's going to be older than 31 BCE, right? That's going to be more like 4,000 years ago. Earthquakes mentioned in the book of Amos, those are also Old Testament earthquakes. And as a result, what he's trying to argue is that the scriptures are faithful. They're a faithful witness. They record for us things that we actually see in the physical evidence. And therefore, we can trust this physical history, or let's say this physical history of the earth actually confirms what scripture says. I think he's right. This is where I actually have some relief that I can discuss a young Earth creationist work here and say that I can agree with all the major findings of this article. I can agree with Steve Austin. I think he's done some excellent analysis here, but there's a huge bit of irony in all this, which we'll get to in just a moment. So let's take a look at what Steve Austin says. So here I have a quote directly from Steve Austin's paper, and this is worth reading. Recently, geologists have investigated a 4,000-year chronology of earthquake disturbances within the upper 19 feet of laminated sediment in the Dead Sea. This is the En-Gedi core. And the En-Gedi core does cover the last 4,000 years. It's a 19-foot core segment, and it covers 4,000 years of history. And you notice that Steve Austin seems to accept that, right? He accepts that this is a 4,000-year chronology. That doesn't interfere with the young Earth creationist chronology yet, because they have 4,000 years, all right? So they can accept that there are 4,000 years of sediments at this particular location. Hypersaline waters preserve seasonally laminated sediment because organisms cannot live or burrow in the bed of the lake, right? Mentioned that before. That's why the Dead Sea is a great place to study seismites. As a result, only a nearby earthquake or very large distant earthquake can homogenize the lake's uppermost sediment layers, producing a mixed layer devoid of laminations. Nice description of a seismite. A sketch of a sediment core from the west side of the Dead Sea appears in Figure 1. I'm going to show that in just a moment. The sketch shows that the depth of the mixed layers within the laminated sediment sequence. Two deeper mixed layers in the Dead Sea are datable from historical, archaeological, and geological associations with faulting, the earthquakes of the 31 BC, the Qumran earthquake, and the 750 BC Amos earthquake. Right, he's going to show where he thinks that earthquake is in this core. Other earthquakes are represented by the Dead Sea sediment core, with dates approximated by assuming a steady rate of sedimentation. Now, Steve Austin isn't the only person to use scriptures to try to locate and identify particular earthquakes and associate them with the Dead Sea cores. There have been secular scientists who study Dead Sea cores who have used scriptures and referenced scriptures as their eyewitness accounts of things that they're seeing in the Dead Sea core. So he's not unique this way, and he is confirming these earthquakes in the same way that secular scientists are also confirming the same earthquakes, the same size. We have agreement between young Earth creationists and secular geologists studying these particular sediments. All right, continuing. Two early Bronze Age archaeology sites southeast of the Dead Sea reveal evidence of catastrophic collapse and burning along the eastern border fault of the Dead Sea Transform Fault. Oh, so now we're finally getting to the part of the title of this particular episode, Sodom and Gomorrah and Seismites. These two cities likely are the remains of Sodom and Gomorrah. There's been a lot of talk about Sodom and Gomorrah in the last couple of years because there's been a report of evidence of, well, somebody has suggested that Sodom and Gomorrah were destroyed by an air blast, right? A small meteorite or asteroid that broke up above this area and created an enormous air blast and heat along with that actually consumed the bottom of the Dead Sea at this point. That paper is really interesting, but it's very controversial. I don't want to go into all of that stuff. That's not what we're here for, but I just want to let you know that there's been so much debate about which of the different communities, archaeological sites might represent Sodom and Gomorrah. Some Christians believe that Sodom and Gomorrah is even below the Dead Sea levels today, but most believe it's somewhere around the Dead Sea. But there's always been questions about whether it's on the northern part of the Dead Sea or the southern portion of the Dead Sea and so forth. But anyway, all you need to know here is Steve Austin is like, hey, there's an earthquake that also is associated with the destruction of Sodom and Gomorrah because it fits right within the right time frame for when the biblical record of Sodom and Gomorrah is. This thick disturbed zone within the Dead Sea sediment core assignable to the Sodom and Gomorrah event occurs at a depth of 18.5 feet. Remember, you've got a 19-foot, he says 19 foot, it's actually like a 20-foot sediment core. And here's his cartoon drawing of where the major seismites are. And again, this is not disputed at all. This is essentially, he's taking this from the secular literature anyway. So right down here, around 2050 BC is a large seismite, and he's correlating that with the destruction of Sodom and Gomorrah. And then you have the 750 BC seismite, and that is the earthquake recorded for us in the book of Amos. You have 31 BC, that's also recorded for us in scriptures, but that's the one that's recorded for us by Josephus. 33 AD, that is potentially the seismite correlated with the crucifixion, the time of the crucifixion of Christ. And then we've got other seismites from known historical records from the last 1,000 years above that. And so you notice that you have, it's a relative, if you, I showed you the figure already, that if you map how much sediment accumulates over time, so just divide 2,050 years by 18.5 feet, and you'll get a sedimentation rate, right? So 18 feet, 2,000 years to lay down that much sediment. Great. You're going to think, okay, that's fine. That's a wonderful confirmation that you have eyewitness reports of earthquakes. You have these things that we call seismites because we think they were caused by earthquakes. They seem to actually match up. And one thing that really extra confirms the fact that these are seismites is that you have all these different forms of evidence that all confirm each other, right? So you have the 31 BC date. Well, you can count varves all the way down. And although there is, I've mentioned, you're not perfect. Nonetheless, if you count the varves down, you're going to get around to 2,000 years. And if you know that the 31 BC one is, if you use that as an anchor point, by the way, you can also do carbon-14 dating from material, like organic material that's in these different layers. And those carbon-14 dates also get you to somewhere very close to what the varve count is. All right, so those two things together confirm, yes, you're in the right range. And once you're in the right range of like, hey, I'm somewhere around, 25 to 50 BC, and wow, here's this huge seismite, and we have this many different historical records of this massive earthquake, and we can see the evidence in archaeological sites of like destruction caused by this earthquake in 31 BC. But then you say like, okay, I'm really confident. 31 BC is right there. It's right there in the column. Right? That is where the bottom of the lake was at 31 BC. Then I can count the varves up from that and date this one. I can count the varves down to 750. And I think that 750 is the earthquake from Amos, because that's the other one we know is highly destructive. And I count the varves between these two, and it's like, yeah, I'm getting about 720 varves between those two. That increases your confidence that, yes, this large seismite at 750 BC, it really is 750 BC. And is most likely the earthquake reported for us in the book of Amos. All right, so all these different things feed back on each other. That's why there is a tremendous amount of confidence in this particular core and what it represents. Right? As a historical record, as a historical chronometer, we're in agreement here. Great. That all sounds good, but you do realize what the problem is, right? And I just don't know what Steve Austin was thinking here. I've heard him talk about this. Surely he's aware that the top 20 feet of sediment in the Dead Sea doesn't cover all the sediment that's in the Dead Sea basement, right? It's like, and he's saying that at 4,000 BC, 4,000 years ago, right? 2000 BC would be about 4,000 years ago. About 4,000 years ago with Sodom and Gomorrah, which is right around, around the time that Lot and Abraham are looking in the Dead Sea Valley, and they're seeing, like I've been stressing in every episode, they're seeing this valley with a Dead Sea and a Jordan River and pretty much like it looks today. He's admitting that that's 4,000 years ago. Well, what about the other 15,000 feet? Where did that come from? If the top 19 feet represents 4,000 years. That is an enormous challenge for young earth creationists. This is one of the most striking disconnects that young earth creationists have, right? They are like compelled to argue that the top 19 feet represent 4,000 years of sedimentation, yet we can just start traveling below that and see that there are thousands of varves below there. And there are dozens and dozens and dozens of other seismites below there that look very similar to the seismites in the first 4,000 years, right? The upper 4,000 years. How do you explain those? Because for young earth creationists, that time doesn't exist. right? We're already 4,000 years ago. The flood is 4,500 years ago. You have 500 years. How are you going to get thousands of varves and literally hundreds of earthquakes into 500 years and have them look like just what the first 4,000 years are? That is a toughie. And it's made worse by the fact that young creationists are completely inconsistent with each other. Here is Dr. Brian Thomas at the Institute for Creation Research. Notice, same organization. 2012, 2 years later. Steve Austin wrote his article in 2010. Here we are in 2012. Deep sea sediment cores confirm Genesis. I mentioned this article in the last episode. I'm going to mention it 2 episodes from now. We're going to look at it more thoroughly. We're just going to talk about the irony here. Brian Thomas, he acknowledges in this article, 2 years after Steve Austin, that 235 meters, 770 feet below the floor of the Dead Sea, there's evidence that the Dead Sea dried up. That's what we talked about in the last episode. He thinks that that is when Sodom and Gomorrah happened. Is this whole article talking about Sodom and Gomorrah and how this is evidence that, everything was super salty. This is when Sodom and Gomorrah happened. It would have been a terrible time in the environment. Right? Something dramatic happened then. And he thinks that drama was the drama that surrounded Sodom and Gomorrah. And where does he find that? 235 meters below sea level. All right, below the Dead Sea level. So just to put a point on it here, Steve Austin in 2010 for ICR makes what I think is a very cogent, very reasonable, really undisputable argument that the top 19 feet of this 450 meter core, all right, he was just looking at the top 20 feet, all contain the last 4,000 years of history. 4,000 years of history. All right, including Sodom and Gomorrah at the beginning of that particular history. So he's putting Sodom and Gomorrah right here. Then I've just, this is this 450 feet showing that we've talked about the Holocene the last 10,000 years. And then you go back to Lake Lisan. That was like 14 to 17,000 years, all the way back to 70 or 80,000 years was this large lake there. We haven't talked about Samra or Amora, which are prior lakes that have existed in the Dead Sea. And so all this sediment, 450 meters, right, and it includes tens of thousands of couplets, tens of thousands of varves, evaporite sequences, and, as I mentioned at the beginning of this, 400 earthquakes. 400 disturbed layers that are seismites, that have the same appearance as seismites in the top 19 feet that everyone agrees are seismites. So 400 earthquakes. Sorry, I'm being really repetitive because I really want to stress this point. Brian Thomas says that at 235 meters below, that's where Sodom and Gomorrah is. So he would have to propose that since Sodom and Gomorrah, 235 feet, 770 feet of sediment have been laid down over the last 4,000 years. But I think it's pretty undisputable that 2,000 years ago, you're only a couple meters. You're only 9 feet below. You're only 9 feet down. So from 9 below that, how did all that sediment get laid down? How did 770 feet of sediment get laid down in a period of just 2,000 years? There have been massive amounts of water, massive amounts of input into the Dead Sea at this particular location in order to accomplish this. And we know there wasn't massive amounts of sediment laid down that because there's lots of evaporites. All right, there's lots of times in that period in which the lake was quite low and there was salt precipitating. Right? And there's not much sediment. It's mostly evaporites. And evaporites can only collect at a certain pace, which is not nearly the pace to cover 770 feet over 2,000 years. You can't have massive amounts of input either, otherwise you're going to have a huge lake. And we know there hasn't been a huge lake over the last 4,000 years. Right? The Bible tells us so. The Bible tells us it is as Steve Austin would say, it is a faithful record of historical events, and it provides us with a continuous record of what the Dead Sea area has looked like for 4,000 years ago, which is basically similar to what it is today. So Brian Thomas has nothing. All he wants to do is explain why there's pebbles in the middle of the Dead Sea and how that could happen and how the Dead Sea could have dried up. Because he seems to be convinced the Dead Sea was dried up. In other words, he looks at that one piece of evidence and is like, yes, obviously the Dead Sea must have dried up in order for us to have this particular layer of material. And then he's like, well, now how are we going to explain that? Like, where in the Bible could I explain that the Dead Sea was much lower than it is today and was completely dried up? Oh, wait, Sodom and Gomorrah. That was a really radical thing. It was earthquakes, everything, all types of stuff was happening then. And it was super salty. So that's when Sodom and Gomorrah was. Right. Did he confer with Steve Austin? Right. He's at the same institution. He does not reference Steve Austin's article in his article about the Dead Sea. Did he read it? If he did read it and he comprehended anything that Steve Austin said, right? Because Steve Austin lays it out and it is so clear and it is so obvious, right? It makes complete sense. Steve Austin's article makes utter and complete sense to me. Fits all the data, fits scriptures, fits the sedimentary record. I mean, it's all a nice, wonderful package. How could he look at that and then say like, oh, well, wait a second, Sodom and Gomorrah, oh no, that was 235 meters. That's 770 feet farther down. I don't think he even looked at it, or he didn't understand it. He's simply just he's doing what most young earth creationists do, which is there's something that comes out because what happened is he's responding to an article that came out in the public press, just like popular press. Hey, they found this weird layer way down 770 feet and people are talking about it like, wow, the Dead Sea dried up. And then, it's like, okay, well, my audience, young earth creationists are going to hear about this and they're going to want to know, like, how do I understand that? Like, where does that fit in the Bible? And so he's providing them with an answer. It's not a very comprehensive answer because I don't think he thought at all about sedimentation. He didn't think about Steve Austin. He didn't think about seismites. He didn't think about any of these things. He just wanted to answer that question. And so it's just like, and he's of course very confident. His article is like, yeah, this is when Sodom and Gomorrah happened. But you know what? It's not. You can see that this is a big problem for young earth creationists. This disjunct, but the problem is far, far greater. Far greater. We're only looking at the top 450 meters, right? I mean, Brian Thomas has a problem. How does he explain the prior 130, 200 meters? How does he explain that? If this is Sodom and Gomorrah and you got 200 meters below that of salt and sediments and varves and all this other stuff and 100 other earthquakes before that, how is he going to explain that as happening after the flood, but before Sodom and Gomorrah? Impossible. I cannot conceive of how that could be explained without employing vast numbers of miracles or just instantaneous creation. Like God just made it. Like he just made those layers because like, okay, I got to make these layers and then we'll start time, sometime later and let these layers actually start to accumulate in reality. But I am still not giving you the full power of this argument against young earth creationism. We are only talking about the top 450 meters, which is a half a kilometer. But I want to remind you, there is 5 kilometers. 5 kilometers of sediments that have been laid down by a lake. 5 kilometers of lake sediments that fill up the Dead Sea Basin. All right. So if you don't remember this figure, I've talked about this in previous episodes. But above the major rocks that have been laid down, which young earth creationists would say would be the flood rocks, above those, this basin layer all has to be laid into this basin sometime after the flood. And that includes our 6,000 feet of salt that's evaporated material. All right. And then thousands of other clastics sediments that are accumulating over time. We're only looking at the top 450, and I'm exaggerating here. 450 is just this little blip up here at the very top. And out of that 450 at 235 meters, that's where Brian Thomas says that Sodom and Gomorrah was 4,000 years ago, which means 4,000 to 4,500 years has to be all of this 14,000 feet of sediment. And Steve Austin is saying that 4,000 years ago is just 19 feet down. 19. I can't even draw it on this graph. All right, so 19 feet below the top layer that's there today. That's where 4,000 years ago is. Where did all of this come from? And when did it get laid down? And how? Because I tell you, the first couple thousand feet below that look just like the top 19 feet. Layers and layers and layers and layers and layers, little couplets of different sizes. It looks like annual rings. We have, as I said before, 400 earthquakes recorded just in 450 meters, which conventional dating is 220,000 years. And remember, all of this is, some 20 million years of deposition. All right, so 220,000 years just in this top section, but lots of time before that. This is the enormous challenge that young earth creationists are facing with the Dead Sea, along with the many other challenges that I've presented in other episodes and more challenges I have coming up in future episodes. Is this confirmation of events recorded in Scripture? Absolutely. I think it absolutely is. So yes, this is a wonderful confirmation using physical evidence for scriptural-based records. Is this wonderful evidence for young earth creationism? Absolutely not. So this is a huge conundrum for creation scientists. We're back in this little gully, right? 20 feet of sediments right here. So this would be similar to the 20 feet of sediments that are at En-Gedi. That 20 feet represented 4,000 years. Right? So this is at least 4,000 years. You're looking at all of recorded history just here in this little wall. And yet you're standing upon thousands of feet that are very similar right below your feet. So this is a conundrum for creation scientists. The situation highlights, I think, the common dilemma faced by creation scientists when dealing with geological evidence specifically from the Holy Land. This is why I'm picking this particular location to talk about rather than the Grand Canyon or something else. I want to talk about a place for which we have historical records of people reporting events, and we can see them in the rocks, and therefore we know the ages of these particular sediments. When they face the challenge of explaining why, the same methods that we would apply here, carbon-14 confirms the dates over the last 4,000 years. Varve counting confirms the dates over the last 4,000 years. It confirms the eyewitness reports from scriptures, right? That should give us increased confidence in carbon-14 dating and varve counting. So the result is we have sort of this geological double standard among young earth creationists. We have methods and assumptions that are accepted when they produce results that fit the young earth creationist timeline. Like Steve Austin, he's accepting the carbon-14 dating. He's accepting the varve counts. He's using them in a way as evidence that the Bible is true and accurate in its reports. But then they just turn right around and reject those same methods when those same methods point to an older Earth. And here they do, if you just start going down another couple feet, right? Hey, I go down this wall and I'm like, hey, this is 50 years ago. And then I've got the earthquake at the time of Christ, and I've got the 31 BCE, and then down here I've got Sodom and Gomorrah. And then what's down here below that? Oh, can't trust carbon-14 data. Can't trust those. Those aren't varves. They can't possibly be varves. All of a sudden, we no longer accept any of those things that were so useful to us before in trying to support and show that the Bible is an accurate recorder of history. So what are some additional challenges to the young earth creationist framework from what we've talked about today? Right? There's several other aspects of the Dead Sea sediment and the seismites recorded there that are challenges to the young earth creationist. There's long-term earthquake frequency patterns, right? The Dead Sea sediments reveal patterns of earthquakes that cluster over millennia, with an average recurrence of large earthquakes every 13 to 1400 years. You can't get an average by only studying 4,000 years, right? You're just studying the top portion. It's going to be not really a very accurate predictor of the future. But if you're looking at 200,000 years, you get a much better sense for just how intermittent large earthquakes are, which gives us a better idea of our risk in the present, right? Young Earth creationists can't use that data, right? Anything below, the top layers right here, all of a sudden is untrustworthy data that can't inform us anything about the present, because the past was somehow completely different, either miraculously created or there was some other thing that we completely don't understand today about geology that explains all those sediments below and why they happen to look like seismites, why they look like they're varves, but they're actually not, apparently. I've just mentioned we've got multiple dating methods that agree with each other. And so when multiple methods agree and point to the same conclusion, that's powerful evidence that those techniques are actually reliable dating techniques. So you can't use that technique in one moment and turn around and deny it the next moment when you're looking at something that looks just the same, right? The 20 feet below the top 20 feet look just the same in terms of the types of laminations that are there, the types of sediments that are deposited. They look just like the top 20 feet. So therefore, the next 20 feet represents another 4,000 years. That's 8,000 total years, which is more than young Earth creationists have for the entire existence of the universe. So what's the big picture here? It becomes clear that Dead Sea sediments present a consistent narrative of Earth's history that extends like way beyond the confines of a young Earth timeline. And that consistency is one of the most powerful arguments, as I've been stressing here, against the young Earth creationist interpretation. And this is my challenge to young Earth creationists out there, is to think about what I've presented here in this episode and prior episodes, and to present some kind of plausible explanation, some plausible hypothesis that would help us understand these things. Look, the Dead Sea is not just an isolated case, right? We have similar long-term records found in ice cores. We have ocean sediments, right? We drill down into the ocean sediments, and we have similar layering there, and we can see evidence of hundreds of thousands of years of time recorded there. We have other large lakes in the world that are accumulating sediments today, and we core down into them. We're going to find longer than 4,000 years there as well. We're going to see that the upper layers represent several thousand years, in which we can be very, very confident. For example, there are lakes in the world that have layers of ash in them, and we can date those ash layers, and we can know from the chemical fingerprint that this is related to a particular volcanic eruption that occurred in like AD 79, like Vesuvius, right? We know that particular volcano and its chemical fingerprint, and when we see that in lake layers, we know we're at 79 AD, and that is only in the top layer of sediment. So if you have like, hey, you only have to go 5 feet and you get to that point. But there's another 250 feet in this particular lake, right? That suggests, and other volcanic ash layers, which can be dated. And you start dating them, you go back 2,000 years, 3,000 years, 4,000 years, 5,000. Whoa, wait a second, but I'm only like 1/3 of the way down my core, and I'm already at 5,000 years using a very reliable method. All right, for the young Earth creationist model to be viable, it's got to explain not just little isolated pieces of evidence, not like Brian Thomas, who just like, why are there pebbles there? Oh, Sodom and Gomorrah. But I never thought about all these other things. You have to explain you have to be able to explain the entire geological record. It has to be a model that's comprehensive. It's got to account for why multiple independent dating methods agree. And why do we see clear patterns of climate change and tectonic activity over long periods of time? I mean, as we wrap up this exploration of the Dead Sea seismic history, we're going to find ourselves with a wealth of evidence that both supports biblical history. I am saying that this evidence supports biblical history, right? Recorded biblical history is very much supported by this particular seismic information. But it does challenge the young Earth creationist chronology, which is a particular interpretation of scriptures. I think it's a perfect example of how science and faith can intersect in complex and I think sometimes surprising ways. right? The seismic record of the Dead Sea sediment provides a confirmation of earthquakes recorded in the Bible. It's a testament to the accuracy of ancient historical accounts, the power of geological methods to illuminate the past, right? And the work of researchers like Steve Austin, they contribute valuable insights into our understanding of biblical history. However, the very same evidence, and again, I know I'm being repetitive here, but the same evidence that corroborates biblical earthquakes also points to an Earth that's far older than the young Earth timeline allows. The thousands of feet that are layered sediments, the long-term patterns of earthquake recurrence, the correlation with climate changes, the consistency of multiple dating methods, they all suggest a history spanning hundreds of thousands of years. For those committed to a young Earth view, these findings present a significant challenge. They call for a reevaluation of how geological evidence is interpreted within the young Earth creationist framework. It's not enough to just selectively accept scientific methods when they seem to support a preferred timeline while rejecting it when they don't. A robust scientific theory has to account for all the evidence, not just cherry-picked portions. And as Christians engage in scientific inquiry, we're called to pursue truth wherever it leads. Sometimes that pursuit might challenge our preconceptions, require us to rethink our interpretations of Scripture. I believe ultimately a fuller understanding of God's creation can only enhance our appreciation for the Creator. We can't be scared of the data like this. The Dead Sea, with its rich geological and historical record, it invites us to dig deeper, both literally and figuratively, right? It challenges us to grapple with the complexities of Earth's history and to continually refine our understanding based on the evidence before us. Now, if you're wondering how I'm going to make a connection between the Bible and these particular sediments, how I interpret these, how do I intersect science and faith as a Christian? I am going to discuss my worldview with respect to how do I integrate the biblical evidence with these particular sediments. That's going to be in the last big chapter of this particular series. So you'll have to wait till then to get sort of my interpretation of all of this data. Now, I've got to tell you a few more things, though, before I get to that point, right? I have to give you all the observations. I have to give you all the facts, all the things that every person who wants to understand the origins of the Dead Sea, they have to know this information in order for them to develop a theory that will explain all those observations. I've got a couple more episodes in which we're going to make some more observations. The next one, part 8, Mount Sodom, a colossal salt pillar that challenges young Earth chronology. We're going to talk about that giant amount of salt, that 6,000 feet of salt that is underneath the Dead Sea sediments. But some of it has been kind of squeezed out of that, and it has risen up and punched its way through the surface of the sediments and has formed a giant mountain on the south end of the Dead Sea. That's called Mount Sodom. And we're just going to look at its origin and the story that it seems to be telling us next time. Until then, thanks for hanging out with me. We'll talk to you later. God bless you. Thank you for watching this installment of the Dead Sea Chronology series. As we've explored today, the Dead Sea region provides fascinating insights into Earth's history and raises important questions about how we interpret both scientific evidence and Scripture. If you'd like to dive deeper into this topic, I invite you to visit my blog, Naturalis Historia, at thenaturalhistorian.com, where you'll find detailed articles exploring each aspect we've covered today, including full references and additional resources. Here's the schedule for upcoming episodes in this series. Each new video builds on what we've learned today, helping us better understand how geology and questions of the Earth's and our origins intersect in this remarkable region. You can learn more about my work and background at joelduff.org. If you found this content helpful, please consider subscribing and sharing with others who might be interested in exploring these important questions about science and faith. Thank you again for watching. Blessings to you and all who are around you.